This is a video on why dividing by zero is illegal in mathematics. Well, you've been told, hey, you can't divide by zero. You can't divide by zero. You can't divide by zero. You can't divide. Why? Why can we not divide by zero? Oh, yeah, you just can't. Don't worry about it. That's basically what all teachers in mathematics tell their students. And I don't like it. I want to tell you why you can't divide by zero, okay? In this video, we will describe why it's not possible. And there's a really good reason why we avoid dividing by zero, as you will see. Well, whenever we divide by zero, let's get the number, some random number, 7, okay? Alright, let's divide it by zero. Okay? What would you want to say it equals? Some people come up with a random number like, oh, well, 7 divided by 0, maybe it equals 5. Maybe it equals 20. Maybe it equals an infinity. Well, if you want to say it equals infinity, well, infinity is not a number, so it can't equal it because it's not a number. Infinity is a concept. So we can't equal a concept. So now what are we going to do? Well, someone may say, okay, it equals 2. Let's say it equals 2. Take a look at what happens if that is true. If we assume 7 divided by 0 is equal to 2, notice that I can multiply both sides by 0, canceling these, so I get 7 is equal to 2 times 0. Okay? But then 2 times 0, anything times 0 is 0. So now I get 7 is equivalent to 0, which is a contradiction. This is a nonsense statement. I know what you're saying. Well, maybe 7 divided by 0 is not 2. Maybe it's equal to some hashtag or some unknown number. Okay? Again, this process occurs. We multiply both sides times 0. I get 7 is equal to 0 times any number. But any number times 0 is 0. And I get that that is a contradiction. This also works when you don't pick 7. It also works for any number. Let's say any number x divided by 0. Let's say it equals some y. Okay? It still doesn't work. I multiply both sides by 0. Cancel out zeros and I get 0 is equal, or x is equal to 0 times y. That means x is equal to 0. Okay? Now, x could be 0 because it's arbitrary, but even if it was 0, take a look, then we're saying 0 over 0 equals something. Some people say, well, what if 0 over 0 is equal to 1? Because, anything divided by itself should equal 1, right? Well, let's take a look at what happens here. When I multiply both sides by 0, the 0 in the denominator cancels, and I get 0 is equal to 1 times 0. Okay? Well, here, 0 is equal to 1 times 0, which is 0. So that's good, right? There's no contradiction here. Look, everything's fine so far. Well, what if I were to subtract that 1 times 0 from both sides? So I get 0 minus 1 times 0 is equal to 0, correct? But then I can factor out a 0. The left side I get 0, factor it out. So then what do I get over here? When I factor out a 0, any number could go here in this place. Any number could go here, and that number times 0 would restore the factorization. Okay? So I have 0 times any number minus 1 is equal to 0, which is true. But then I have 0 over 0 if I divide both sides. If I divide both sides by 0 here, divide both sides by 0 here, I'll move this argument to the left here. Moving this argument up here, then I get any number minus 1 is equal to 0 over 0. Okay? But any number minus 1 equals 0 over 0, but 0 over 0 should have equaled 1, right? We assumed 0 over 0 equaled 1. That was our original assumption. But I can pick that number, this hashtag looking thing, I can pick it to be 5 because it's arbitrary. So then I have 5 minus 1 is equal to 1, which is equal to 0 over 0. But that's not true because 5 minus 1 is 4, and that does not equal 1, which is not equal to our supposed 0 over 0. So as you can see, even when we claim 0 over 0 is equal to 1, it doesn't work out. Once we do algebraic operations and we try and solve for variables like we normally do, it results in contradictions. And therefore, these contradictions are the very reasons why we do not allow division by 0.